Okay, this is notes 1 representing categorical variables with graphs. So starting off, we have statistics is the study of data. Okay. Data contains information about groups of individuals. The information is organized using variables. So when we talk about individuals, we're talking about not only people, but it could be animals or inanimate objects. So anything that we are studying. And then variables take on different values, and we can split these into two categories, one categorical and the other quantitative. Categorical variables means that we are placing the individuals into groups or categories. And quantitative variables are variables that take on a numerical value, but also make sense if we do an operation like adding or averaging. Quantitative variables fall into two categories, discrete and continuous. So when you see the word discrete, when we're looking at quantitative, I want you to think something that you can count. Okay, so 0, 1, 2, 3, 4, etc. And then continuous, I want you to think a decimal. Okay, however, as we're looking at some examples, you'll notice that some things that include a decimal can actually be categorized as discrete. So first, looking at some examples for categorical, it's anything that we can place in a group. So for example, we could say favorite color. Okay, blue, green, pink, red, etc. Those are all different types of colors. We could do shirt size. Okay, extra small, small, medium, large, etc. We could do grade level. So freshmen, sophomores, juniors, seniors. We could do, trying to think of some examples you guys mentioned in class. Dog breeds. Okay, there's different types of dog breeds. And then we could also do music genres. Okay. For quantitative, we have two categories. We have discrete and continuous. So discrete is something that you can count. So for example, that could be the number of pets that you have. Okay. It could be your heart rate. Okay, so when you check your pulse, you're counting every time that your heart beats, and you're counting it 1, 2, 3, 4, not 1.1, 1.2, etc. And then another example that you guys gave was number of people. And then continuous is usually something that is a decimal and then something that we can measure. So we can measure your height. Okay. We could measure your weight. And we can measure time, okay, because time is hours, minutes, seconds, milliseconds, etc. It says just because something is a number doesn't automatically make it quantitative. So number does not automatically mean quantitative. And some examples of that would be your zip code. Okay. Let's say I was to ask everybody what their zip code was, okay? And then I was to tell you, okay, now let's take the average of everybody's zip code. Well, that doesn't make sense. If we take the average of everybody's zip code, for one, that's not telling us anything. And for two, we could end up getting something like a decimal at the end, like 0.5, 0.4, and there's no decimals in zip codes. So this would actually be categorical. Another example could be your phone number for the same reason. Okay, and here just emphasizing that discrete is something that is counting, and continuous is something that has decimals where appropriate. So The difference between discrete and continuous is not always concrete as, okay, can you count it versus having decimals. There are special examples, and one special example is age. Okay, when you go up and tell somebody your age, you don't say, oh, I'm 17.895 years old. You just say that you are 17, 18, 19, 20, etc. So age is discrete. Okay, another good example would be shoe size. Okay, well, you would think, okay, well, shoe size has to be continuous because we can have 7.5 as a shoe size. Well, however, we only have those whole numbers and those decimals of 0.5. So technically, we can count shoe sizes. You can have a 5, a 5.5, a 6, a 6.5. There's not something like 5.5, 6, 7, 8, 7.8923 shoe size. Okay, it's only those two, and so shoe size would be discrete. Okay, now let's look at two ways to represent this data, and we can represent it in a table or in a bar graph. So first, looking at our example, it says here is a list of the first 10 U.S. presidents, their political party, and their state of birth. So if I was to ask you, what are the individuals, you should tell me the individuals are the first 10 U.S. presidents. It's very important to be extremely specific when you're talking about your individuals or what you're studying, because if someone just said presidents, well, that doesn't specify presidents from where. Okay, U.S. is not the only country that has presidents. And so it's very important you say the first 10 U.S. presidents, very specific. And then the other parts, political party and state of birth, would be our variables. So here we have a list, and we're going to first just create one-way tables. So what these one-way tables do is they break it down per variable. Okay. So looking at our first variable, which is political parties, we're going to count how many times they pop up in this list. Okay, so looking at the list, I see that there are 2 Federalists, 4 Democratic Republican, 2 Democrat, and 2 Whig. Okay, and I'm going to do the same for the second table over here, and I'm going to still count, but here they're using the fancy word frequency. Frequency and count are the exact same word, okay, with the same meaning, just 2 different ways to represent it. So we're still counting. So again, if I go back up to my list, I see that there is 6 that were born in Virginia, 1 in New York, 1 in South Carolina, and 2 in Massachusetts. Okay, and now that last column here where it says relative count and relative frequency, this is going to be a percentage. So anytime you see the word relative, we know that it's going to be a percentage. And we find that by doing count over total or frequency over total. So ultimately what we're going to get is a proportion. So our total is 10 U.S. presidents, so this would be 2 over 10, or we can represent that as a percentage of 20%. Which means Democratic Republican would be 40% as the relative count. Then we have 20% and 20%. And then in the next table, 60%, 10%, 10%, and 20%. And then notice, as we look at all of these percentages in our relative frequency, you should notice that if we were to add them straight down, we would get a total of 100%, meaning we utilized 100% of our data. If you got any other number besides 100%, then you know you did something wrong. Okay. Same with these columns here with count and frequency. Remember, we had 10 U.S. presidents, so that means our total for each of the counts and frequency should add up to 10. Okay. But one-way tables are tedious. Okay, do you really want to create a table for every single variable that is in your study? No. Instead, we could create what is called a two-way table, and this helps us visualize the data a little easier. So how you fill out a two-way table is you look at the column and the row. So you need to find how many Federalists were born in Virginia. Well, if you look back up our table, you'll see that's 1. And then you do how many Federalists were born in New York, and you just continue down for each one. Okay, so if you want, you could pause this video, try to do it on your own. Okay, I'm going to go ahead and fill it out, and then you can check your answer. And again, I'm finding all this information in the list that was provided to me above. And the most important thing is this last box here. Notice that this is the total of the total. And that total adds up to the number of individuals, okay, that we were studying. And so if this number did not equal 10, again, that would tell yourself that you did something wrong in your math, okay? Now let's look at graphs. The reason why we represent data in graphs over tables is it helps us better visualize a distribution. And a distribution of a variable tells us the values the variable takes and how often. And for us, it's a lot easier to look at for example, bar graph, and be able to easily identify certain aspects of it instead of having to read a table and compare data that way. Okay, so when you are asked to look at a distribution, most often it is in some type of visual graph. Well, right now we're going to look at bar graphs. And bar graphs, in order for you to get the full points on the AP exam, you need to make sure that you label each axis clearly. So what is the x-axis? What is the y? The x-axis is the categorical variable, and the y-axis is the counts or percentages. Remember when we saw the word percentages, we said that that is like frequency, the relative frequency. Each category has its own bar, and bars cannot touch. And then the last thing is not so much what I'm looking for, but just a piece of knowledge for yourself. Order does not matter. Because if we're talking about categories, let's say I'm asking you your favorite color, okay? And we have the options blue, green, red, pink, okay? It does not matter if you put pink before blue or blue before pink, okay? It's not like they're numerical and it matters that you put 1 before 2, okay? So the order does not matter. So what we're going to do is we're going to create a bar graph of the 4 political parties of the first 10 U.S. presidents. So remember, the first 10 U.S. presidents were our individuals, and the 4 political parties is our variable. Okay, so drawing my bar graph, I know that this is my x-axis and this is my y. And on my x-axis is always the categorical variable. So in this case, the political party. And we had 4 political parties. We had the Federalists, which I'm going to abbreviate. We had the Democratic Republican. We had the Democrat. And then we had the Whig. And then remember, your y-axis is your counts or your relative counts, relative frequency, your percentages. So if we go back to our table, we'll notice that for political party, and I'm going to go back up to this table here. The political party, our greatest count was the number 4. So when I'm creating that graph, I'm just going to label 1 through 4. So 1, 2, 3, 4. And then I'm just going to start filling in the data. So for Federalists, looking back up at my table, I know that I had 2 Federalists. For Democratic Republican, I had 4. For Democratic, I had 2. And for Whig, I also had 2. So notice, looking at this bar graph, I can easily, right off the bat, see that the Democratic Republican had the most affiliation with the first 10 U.S. presidents. So looking at the questions below, I answered number 1. And it says, of the first 10 presidents, what political party was the most affiliated? So which one had the greatest, which one had the largest bar graph? And that was the Democratic Republican, which I'm still just going to abbreviate. Then it said, what political party was the least affiliated with? Well, notice that all of these right here are at 2. So that means we don't have just one that was least affiliated. We have a tie. So I would say a tie between Federalist, Democratic, and Whig. And then lastly, we answered this question at the very beginning before we drew our bar graph. It said, what are the individuals in this data set? Well, we said the individuals are the first 10 U.S. presidents. And then what are the variables? Well, we only have one variable, and that is the political parties.